Hey guys, it's Elliot Kipling here from Engineers. Welcome back. We've got Allen Rohner here. Allen has co-founded a business previously that I'm sure you guys will know, CircleCI. He's also co-founded a business, Griffin, who we're going to talk about today. So Allen, say hello. Do you want to give us a little intro into you?
Yeah, hi, thanks for having me.
Pleasure.
Yeah, so I've been doing startups for more than a decade now. Had a little thing before Circle, it didn't go anywhere. Co-founded Circle in 2011. I was there until 2014. And then since about 2017, 2018, I've been working on Griffin.
Nice, okay. Before we go into Griffin, London-based, we can talk about some of the challenges that you've got in banking, etc. Talk to us about the experience at CircleCI, because this is going to be tooling that a lot of guys and girls listening to this podcast that have used, that understand. So can you talk to us a little bit about that and maybe your mindset in 2011?
Sure. So in 2011, I didn't know anything. So started this, I know more now, but I wouldn't say I know everything. So CircleCI is a hosted continuous integration and deployment. I guess it started from my own need at my previous startup, which was that, so at the time, GitHub was just starting to become a thing, and AWS in the cloud was just starting to become a thing. And so I was doing the modern best practices of GitHub and pull requests and then continuous integration and then deploy to the cloud. But at the time, CI was Jenkins, or it was something. Hudson was the name before that, and I had to install it on a box that was sitting under my desk. And I thought, well, this is stupid. GitHub's in the cloud, AWS is in the cloud, but in the middle, it has to go under my desk to run tests. Yeah. So I thought it was a good idea. Moved to San Francisco and just started doing it. The tools at the time were not very good. So like Ruby bundler was new. There was no Docker, there was no Kubernetes. AWS was EC2, so there's no Beanstalk, no EKS, no Fargate, no Lambda, no serverless.
Yeah.
So I'd say a lot of the pain was just working through the tools and then me not understanding distributed systems and what it actually means to run a business at scale. Yeah. So a lot of it was just learning how to scale up something that was computationally intensive and had a lot of reliability requirements. I'd say learning it the hard way.
Yeah. Okay. Well, what did you learn about building a business at scale? That's probably a fairly off-the-fly question, but what are some of the standout points that you think I would definitely apply that again, given the opportunity, hopefully with Griffin?
So I'd say market size is a big one. So I think I learned from a Hacker News comment once, which is that basically all startups are the same level of difficulty, which that's not 100% true. Sorry, I have to let the dog out.
Yeah,
that's not 100% true, but you're going to spend 100% of your time and effort for the next 4 years on a project, and so it doesn't really matter, whether it's a to-do list or a bank. You're going to spend 100% of your time on it, so therefore you should pick something that is going to reward you for the effort. I'd say a lot of the things I learned about from market side, like you go from market to demand. So like make sure there's enough people out there who are willing to pay money for the thing.
Okay.
And then build something that people want. Just the standard YC advice, but it's true and it's hard to make that simpler. Yeah. Get something into people's hands as quickly as you can. And one thing I noticed was that we had a bunch of beta users who were using the system for free. And we'd ask them, oh, how do you like it? And they're like, oh, it's great. Love everything about it. Keep doing it. And then one day we said, starting next week, we're going to start charging you credit cards.
Yeah.
And they went from everything's perfect to like, here's 100 bullet points of things you need to fix. And so that was like where the rubber met the road, and you get significantly more clear feedback as soon as you try to start charging people.
I was just about to say, how do you find out what people need? Sorry, find out the demand and then find out that pricing. There's going to be a big gap in between where, like you say, people start to become unhappy with what you're actually building.
Yeah, that's a hard art in itself. You can kind of think about the size of the pain point, and then you think about how much you can charge them and who are you charging. So, if you're charging for a mobile game, so individual purchases, your price is going to be, either free or, call it up to 60 pounds if you're doing a, AAA game, but you're not because you're one or two people. But then you get and then there's kind of a sliding scale of, things you charge. You can get an individual to pay 50 or $100 a month, and then you get into like selling to small businesses and selling to large businesses. And the important thing to remember there is that the buyer changes, especially going from consumer to businesses. And then, if you imagine if you're selling to startups, you can charge, to a team of 10 people, you say like, oh, $50 a month on your credit card, fine.
Yeah.
But then if you get into like these massive enterprise deals where you're charging like $1 million a year, suddenly there's this whole org chart that you have to understand, and the user and the person with purchasing authority and the person paying it for the product are all different.
Yeah.
And so like enterprise sales is very difficult because your salesperson has to go in and understand the structure of the company. And they have to say, okay, who are all the people involved and what are their motivations?
Yeah.
Because the person paying for it isn't the person who actually feels the pain. And so that's a whole other struggle.
Yeah.
So for startups, I would say the sweet spot is sell to small startups that are growing. So like with Circle, our original customers were startups that were about the same size as us. So we were, two guys in San Francisco, and our initial customers were San Francisco startups that were 2 to 20 people.
Yeah.
And then as we grow, our customers grow, and then both sides can kind of mature in the sales process at the same time.
Nice. Okay. I think you hit the nail on the head, really, with the motivations part and understanding the whys. Like you say, someone paying for the product, someone using the product, two different things.
Right.
Okay.
And there are pains that not everything is easy to solve. Like just because there is a pain point doesn't mean that someone will pay for that. Yeah. So the great example I love to use is paying for coffee. Like if you're a coffee drinker, you don't make a choice to say like, am I going to buy coffee today? Like you're just, yes, that's going to happen.
Yeah.
But then try to get somebody to pay $5 for a mobile game or whatever, some iPhone app.
Yeah.
There's all kinds of, $5 is a lot on the App Store. It's like, you did not think about the price of coffee today, and then you're going to go into this whole decision-making process of, do I really need this £5 app?
So true.
Yeah. So I had as an example of that, I had a startup idea that I couldn't convince anyone to buy, which was website performance monitoring.
Okay.
And that you can find all kinds of evidence for, like you go to like Walmart and all these major brand names.
Yep.
And Amazon, they have extremely good metrics that the speed of your website will directly affect conversion rates.
Okay.
And to the point where like Walmart.com can make like 20% more money if they make their pages just a little bit faster.
Okay.
And so the empirical research on this is very good. And so I was trying to make a startup that would, measure
a little bit like App Dynamics for websites.
Yeah. And then, sorry, my monitor is, there we go, okay. So it'd measure the performance of a website on page load times and then tell you how to improve it, which would directly lead to conversions. And like, I'm quite convinced that pain is real. I'm quite convinced companies could make a whole lot of money if they made their websites faster. But finding the set of buyers and payers was just a complete nightmare.
Sorry, no, please carry on.
So the problem there is that in most startups, the engineers, in startups big enough to be worth paying for this, the engineers would know it's a problem, but they're not motivated to improve sales. Okay. And then marketing maybe doesn't believe me that there's a problem, or they're not convinced. Or so like, the problem is real, but you need to find the right set of conditions where somebody's willing to pay for that.
What is that difference in speed that could generate 20% more revenue? Do you know that figure? Only because that's a lot. 20% is a lot.
I'd have to go pull out my notes, but I want to say that page load times should be under a second, and a lot of e-commerce sites are in the like 5-second range.
Okay.
So and for the most part, you don't need any special tricks. It's mostly just doing the things that we already know how to do. CDNs and compress your JavaScript and minimize your JavaScript and nice. All that kind of stuff.
Okay. Moving on to more startups then.
Sure.
You've got bundles of ideas in that head. I love it. Talk to us a little bit about Griffin. Give us an intro into Griffin and what sort of challenges you're trying to solve in what's commonly described as a fairly fractured finance and banking industry.
Sure. So Griffin, we are trying to become a UK bank. And the goal is that we would be the bank for fintechs. So we kind of have to talk about the law a little bit here. So by law, anytime a company wants to hold customer money, eventually that money has to be held at a bank. So if you're a startup that wants to do the next Tide or the next Anna or a prepaid card startup or retirement accounts, I guess you call them pension accounts here, FX, like any kind of startup that wants to touch or hold customer money, the money eventually has to end up at a bank. You can, in the UK, there's EMIs and PIs, but by law, they have to keep the money at the bank. And the banks are uniformly terrible to work with. Most of them don't have very good APIs. Most of them don't have modern technology. It's very difficult for them to even get a bank account in many cases. I think Griffin, personally, we spent something like 8 months trying to get a UK bank account. And the bank account we currently have, we can't keep once we become a bank.
Okay.
So the idea is we will take care of all of that for you and kind of like a mix between Stripe and AWS, but for fintechs. So API first, online only, modern best practices on the API side. And then integrated compliance, which sounds really boring, but that's kind of one of the ways we think we can fix this problem.
Yeah.
More legal background. So if you have let's say you have a fintech, and we'll say you want to do the next Tide, like a mobile app that has a digital current account. The way, so I'll say Tide, but like you can imagine, or the next Revolut, it's the same kind of deal.
Yeah.
Typically what the big banks will give you is a single pooled account. And so then that means that all of Tide, your 10,000 customers, all of their money will live in the same in the same pooled account at Barclays or whoever.
Okay.
And so then that means you need to build a ledger to keep to say that your money is separate from my money. And then the other big risk factor here, and that takes a lot of time and money. I was consulting for a company once where they spent like £3 million building their own ledger to handle a couple thousand transactions per second at scale.
Okay.
So going back to compliance, and you have this single pooled account, the other big thing that banks are responsible for is money laundering and making sure that nobody sending or receiving money is on the terrorist watch list or anything like that. So there's a process, they call it KYC, where you have to verify the identity of every customer. And so the big banks can do this, but it's very expensive, and they might charge like £100 each. So if you have your 10,000 customers, as a fintech, you don't want to pay that bill. So then the bank says, okay, you, the fintech, can do it. Here's our 500 pages of procedures and policy on how to do this. So then the fintech starts doing that. But the problem is the big banks' fraud and risk algorithms aren't really set up for fintechs. They're still set up for 30 years ago, where you'd have individual retail accounts. So inevitably what happens here is the fintech, if they're successful, they have a big spike in transaction volumes and new cases, and then that triggers the bank's fraud and risk algorithms. The big bank gets twitchy because by law, the bank is not allowed to delegate its responsibility for compliance. So if the fintech screws anything up, the bank gets in trouble with the regulators. The bank doesn't want to get in trouble, so then they de-risk the fintech off the platform. So one of the ways we think we can solve this problem is if we design the system so that we can give the fintech, an individual account for each of the fintech's customers. And then we will do KYC and compliance, and so we can verify all of the fintech's customers are, we can verify all their identities and make sure nothing illegal is happening. And we think we can do that, if we use the modern regtex, so it's kind of like the same kind of system that Monzo is using. If we apply that and we have visibility into all the fintech's customers, then we can onboard fintechs significantly faster and cheaper than the big banks do. And then because we know, rather than everybody's money being pooled together, they're all segregated, we can say, we don't like that one customer. And so we can kick off individual fintech customers without having to kick everyone off the platform.
In my head, I quite like to think of you guys as like a banking platform as a service and authentication coupled in there. So I think that's probably my simplified mind. With building those, if I've heard this correctly, with building those individual ledgers from those pools that the banks create, how difficult is that to do that?
It depends on scale. So, if you say, I want to build a ledger, you can do that in an afternoon using Postgres, fine. The hard part is kind of the scalability and operations side of it, and then depending on your business model, you might need serious scale. So on the reliability side, it's, you need to make sure you have backups in multiple regions. You need to make sure you have 99.99 whatever percent uptime, and then scale. I was consulting for a fintech once, and because of their business model, they were a peer-to-peer lender, and they would, you'd have a loan on one side, and then you'd have investors who might be, pensioners or sometimes just wealthy people who wanted to return their money. So you don't want a single pensioner to own, 100% of a loan for, a restaurant kitchen. So they would diversify it. So they'd have, 1,000 pensioners would each own 0.1%. And so then they would have, 10 or 20,000 outstanding loans at a time. So then every month you'd have 10,000 loan payments coming in, and then each one of those would be sharded twice. So you'd have 2,000 transactions out. So you had principal and interest for each one of the investors. And so this just created massive database load. So they had to handle, thousands of transactions a second. And those are exactly the kind of customers we want to take on at Griffin. And if they had to spend, significant time and resources getting to that scale, and they are one customer, we want to do that for, dozens or hundreds of customers like that. So that's the challenge. Isn't just having a ledger; it's having a ledger that is backed up and secure and reliable and scalable all at the same time.
Okay, and banks pay you for this service?
Banks typically build their own, or they get it from a core banking vendor.
Okay.
So I would say it's more often that the old banks bought most of theirs, and then the newer banks like Tide and probably Starling built their own, would be my guess.
Yeah, nice. Okay. Can you talk to us a little bit about the technology that you're building and how
Sure.
that might work? You're talking about multi-regions important, scalability is important, but talk to us about maybe some of the technology and what you're
Sure.
actually building.
So we are 100% Clojure shop. The technology is Clojure, Kafka, Datomic, AWS, Kubernetes. I've been using Clojure since pre 1.0, mostly just because I like it. Circle is written in Clojure. Griffin is written in Clojure. So Kafka is our primary data source. It's the source of truth, and this goes back to the scalability thing. So one of the great things about Kafka is that the setup of dealing with topics and partitions is annoying, but once you get it correct, you can say, oh, I need more parallelism on payments or whatever. And so, excuse me. So you can go from 10 partitions to 100 partitions, and everything should just be correct and it should just work. Okay. So in terms of scalability and replication, so Kafka is great because you can have multiple brokers holding your data. You can do hot replicas. You can, sorry, just take a step back. At the end of the day, everything is just a Clojure map, and it's a Clojure event, and then there are topics. So then it's easy to back up and restore just a sequence of events, and we can know that we have all of them. Nice. It's easy to replicate them into another region. It's easy to back up the whole stream on S3, and then you get failover pretty easily because you'll have a broker hosting multiple topics and multiple partitions, and then the Clojure code are these little, we call them log processors. Mm-hmm. And if you have 5 of them running and there are 10 partitions, then great, each one takes two partitions each. But if you can add more Clojure processes and you'll get things a little bit faster, or you can just if one of them fails, then it'll take over automatically. It buys us a lot of great things.
Nice. Okay. Any other considerations, I guess, in terms of languages, or were you just thinking, no, this is 100% Clojure. I know what I'm doing. That's what I'm going for.
Mostly, yeah. If we have some performance sensitive code, I would probably look at Rust. And I know that some other UK fintechs are looking in that space. There was a nasty issue with one of the banks running with FPS a year or two ago, where I don't remember the exact details. The reports on it are public. But FPS, the wire protocol, is pretty gnarly compared to 2020 best practices. So it's a binary protocol. It's TCP based, and then they specify you must have this many TCP sessions open, and this session will read messages and it'll write messages. And so it basically has to be native code. Mm-hmm. And if I remember right, there was some C code that was being called by Java. And so the bank thought that everything was fine because their Java code was correct, but there was a subtle memory corruption issue in the C code, and that was causing them to get some bad concurrency problems. So something like Rust, where you get memory safety and speed, is compelling.
Okay, yeah, I've heard the same. Actually, we've done a really similar podcast previously. where some guys in the open banking space, they built some of their services in Rust, which I thought was quite interesting. What technical challenges with the banks or with Griffin do you foresee that you're thinking into maybe a technical roadmap?
Reliability is the big one. So I would say, the banking regulators, their number one job is to make sure that the banks don't fail and the consumers don't get harmed. And I'd say, well, I don't want to. So, coming very closely behind making sure the financial system doesn't fail is making sure individual banks don't have significant downtime. Because banks having downtime is extremely bad. Your cards don't swipe. People can't get on the tube. They can't buy gas. They can't pay rent. Like, it's extremely bad. So that means that we're preparing to go live with, ideally at the end of next year, and I think we'll have 20 or 30 engineers at that point. And so we need to be significantly more reliable than you would expect from a company with 20 engineers. So security has to be good. Security has to, everything has to be much more mature. So you'd have to have very good security, very good reliability, very, backups, multi-region failover, 99% uptime, several nines uptime.
Okay.
But then of course you're a startup, so you still have to ship code. So, if we get everything released and then our processes are so slow that we never release a new feature, that would also could threaten, the existence of the business. So you need you have built a small number of engineers, and you need to get everything right, and you need to ship new features. And so that combination is pretty challenging.
How and what sort of processes do you think you might introduce to make sure that you can do that? I'm sure you've done similar things in the past.
Yeah, a lot of it comes down to testing. Actually, it's just testing and a strong continuous deployment pipeline. So, the system has to be designed for testability at the start, because so actually Kafka buys us a lot there. So the entire system is just a stream of events. So we have dozens of these little Clojure log processors, or procs for short, that just take an event and emit events. So unit testing is very easy, because you can just give a little proc a stream of events and say, here are all the input events, here are all the output events. And so it's pure, it's stateless, it's fast. It's fast because we don't even touch Kafka at that point. These are just Clojure transducers, if you know what that is. So for the non-Clojurists here, you can imagine like map, filter, and reduce. The standard kind of functional programming things. Normally it takes a list and returns a list, or takes a vector and returns a vector. It's a concrete data structure. Clojure transducers are the same idea, but you abstract away the idea of a list or a vector. So it doesn't matter what the input source is, and it doesn't matter what the output source is. Like, the important part of map is, n messages come in, I run my mapping function on each of the n events, and then I return n output messages. So once you have Clojure transducers, you no longer have to go from list to list. You can just say, I want to use core async channels, which are kind of like Go routines, or in our case, we just plugged in Kafka. So in production, you have a stream of events coming from Kafka and the stream of events going to Kafka. But then in testing, we can replace all of that with just in-memory data structures. So so that means we don't have to stub anything. It's just Clojure maps, or list of Clojure events, run the transducer, list of output events. It's very fast, it's very clean. So going back to design for testability. So we do that. A lot of generative tests. which is another, I think that started in Haskell, but it's been ported to Clojure. If it's in your language, you should look into it. The idea is, if you think of like a function, let's say square root, it's like take a number, return a number.
Yep.
And then you can declare that in your type signature. This function takes a number and returns a number. So in generative testing, you say, any number? So the generative tests know how to generate new data of that type. So like on a number, it's just, I'm going to generate any random number. And then I'm going to, your type signature says you take any number and you return any number. So I'm just going to generate a whole bunch of random data. And then if at any point it doesn't satisfy the contract, it does a thing called shrinking, which you need if your tests are any kind of heavy, if you have any kind of size on your tests. So it says, okay, the random sequence XYZ resulted in an exception being thrown. And so then it tries to shrink the data to the smallest test case that will still make it break. So generative testing is great. Highly recommend you look into it. And so that's all on the CI side. And then once we have a green build, then deploy to staging. And then in staging, we run a bunch of other tests that don't really fit for unit tests. So we do Jepsen testing, which is another thing you should look into. So jepsen.io, I think.
Okay.
It's this Clojure guy who's an expert on distributed systems. Okay. And you have Mongo or MySQL or whoever, or Kafka or Postgres, any distributed data store. They'll announce, oh, we have this new feature with read replication, for example, and they say, if you have a 5-node cluster, it'll survive a loss of 2 nodes. And this guy Afir goes, really? And so he'll set up a little cluster of 5 VMs, set up everything the way the documentation describes, and then he'll start messing with the cluster. So, send a bunch of traffic through this database and then just start turning off nodes. Or sometimes the consensus algorithm is time-based, and so it'll say, oh, well, I'll just turn the clock on one of these VMs 24 hours forward, and then I'll turn it 24 hours back and see what happens.
Nice.
And then at the end of that, you build a model and you say, okay, well, I sent these input read and write events, and I would expect these output events based on how the system is supposed to work. But what I actually got was this other thing. And so you kind of have you build this correctness model of what you expect to get and what you actually get, and then say, okay, the system breaks if you do this thing. And so there are all kinds of, it's kind of like chaos engineering.
Okay, yeah.
It's kind of like chaos engineering, but you have like an expectation of what the system should do. So
you really are a Clojurist, aren't you? You're a true one.
Yeah, it's been my primary language for more than a decade now.
Nice. So summarizing that, I think good automated workflow, is really, really, really key for you guys.
Yeah.
Some good process and good principles to ensure that fast delivery as a startup, it's key.
Yeah, absolutely. And I would say you have to lean on this kind of thing. You have to lean on the automated tools because humans are fallible and they're not really scalable. So right now we have 130,000 lines of Clojure, and a good developer can write tens of thousands of lines a year, and we're going to be 20 or 30 developers this time next year, and if everything goes well in 5 or 10 years, we'll have millions of lines of code.
Yeah.
You can't, a human code review, you should do code review, and it's absolutely good, but you can't assume that it will catch all bugs.
Okay.
And so you have to keep increasing your testing.
Okay. And is that something that you embedded in CircleCI quite early on as well?
Yeah. So, we were doing the testing. I would say the other thing that I learned while I was there is that incremental deployments are also extremely valuable. So, if you have, let's say your production cluster is 100 machines, flipping all all of your 100 machines to the new code all at once is risky and ill-advised.
Yeah.
So, because inevitably there will be things that your tests don't catch, and so if there is an issue that your tests don't catch, it would be better if it impacted a smaller percentage of your customers than all of them all at once. So
risk, rule number one.
Yeah, and even aside from harming the customers, one of the fun things you see is that sometimes problems get worse because you've flipped all the machines on all at once. So instead, do incremental rollout. So maybe you deploy your new code to one of the 100 production machines and let it run for an hour and watch the alerts. And okay, if that worked, okay, roll it out to 10 more machines. Watch that, and then slowly roll it out all the way across the board. Your other option there is feature flags, where just because you have new code doesn't mean it has to. Let's say you wrote new code with new features in it.
Yeah.
Just because the new code is rolled out doesn't mean that your customers have to see the new feature. Okay. So you have a little flag that says, do I show this new, do I put the new feature on the UI? Is the new button there?
Okay.
And then you can do all kinds of fun things. So you can roll it out and then say only users who are logged in as internal employees get to see the button, and you can run that for a month, and then you have your list of external customers who've signed up to be beta testers. Yes. So you can look at their email addresses and tie, does the customer get to see the new button, and you can do it on a per account basis. That's really useful as well.
For the non-Clojurists who are listening, you guys want to scale up, for the next 12 months. Do they need to come from a Clojure background? If not, what sort of engineering, let's just say mindset, languages, environments have these people preferably come from?
Sure. Yeah. So say we are hiring. And we'll be hiring forever, hopefully. We are hiring continuously for the foreseeable future. So when I started Circle in 2011, there were no production Clojure jobs. It wasn't an option. So I'd say we're experienced at hiring non-Clojurists. There's a lot more professional Clojure out there now, but it's still somewhat niche, and that's actually something of an advantage. In terms of hiring, I would say the biggest thing we look for is curiosity and desire to learn, Clojure or other weird functional languages. So, people who've, learned Scheme or Haskell or Erlang or, anything else weird and random like that. The other big thing we look for is distributed systems experience. Because of this Kafka architecture is quite novel. And, we all have the intuition of how to set up a normal web-based a web app, using Postgres. It's like, oh yeah, there's going to be a users table and there's going to be a whatever table. That intuition is pretty well established at this point. And with this Kafka stuff, it's quite new, and it took me a couple months to get my head around it. So the distributed systems knowledge is really useful for things like, if I pass a message from, this proc to this proc to this proc, what are the properties in terms of liveness and eventual consistency, and does this system require, what consistency level does this flow require? If let's say it's user credentials and we create a new user in the system, how long, what are the message flows before the user is able to log in, and then if we disable their account, how long are they still allowed to log in before everything takes effect? And so then, sometimes you care and sometimes you don't. And so having a good intuition on that is good.
Okay. Multi-region experience, nice. Do you think at some point you guys might consider trailing outside of the UK?
We would like to. Our initial focus is on the UK, but yeah, we would like to be able to solve this kind of problem in a lot of countries.
Okay. Picking up on what you said earlier about enterprise sales and banking's archaic, have you got problems? I wouldn't say sussed out, but are you anticipating there to be some challenges around how you actually integrate and work closely with banks? Do you think there's going to be some reticence to what you guys are building?
Probably not. So, and that well, I don't want to make it sound easy, but in enterprise sales, there are easier and harder deals. So you can imagine, let's say something like CircleCI on enterprise sale. In this case, you would say the developers would go to their boss and say, I want to spend X, and so actually the classic example is like companies that treat where they think of like, I have a profit center and a cost center.
Yeah.
You never want to sell to a cost center. Like that is a terrible, hard business to be in because the company doesn't even want that department. And so they think I'm going to spend as little money as possible on that. So if you are selling to a specific department in a company, it's better to sell to the profit center.
Yep.
And it's even better to sell to the CEO. So like the person, whenever possible, you want the person with purchasing authority to be the person who feels the need and has the budget. So with the bank and fintechs, we think the problem will be a little bit easier than some other kinds of enterprise deals because the CXOs will feel the pain. And CXOs have the budget authority. And we don't think this will be try to figure out how to phrase this. We know we can't close everyone all at once. So our initial customers will probably be fintech startups, fintechs who've just raised money and need a banking partner to get started. The larger companies will come, as they feel the pain and as we get more, as Griffin gets more mature and more able to handle all their quirky use cases.
Okay. We spoke earlier as well about, there's been terrorist groups that obviously operate for fraudulent behavior. Well, where does that reliability and ownership come when you're obviously doing this authentication piece for banks? Where does the reliability and ownership piece if something comes?
So actually, we are doing it for the fintech because we are the bank.
Sorry, that's what I meant. Yeah.
Fintech. So the law is the banking regulations say that the bank is always responsible, and in some cases, both sides are responsible. But importantly, the bank can never delegate it to the fintech, so we have to do this.
Yeah.
So we'll have integrated onboarding, integrated transaction screening, integrated transaction monitoring. Sorry, I'm not sure I answered that fully. Was there anything else? Was there another part of that question that I didn't answer?
No, I think you're good.
Okay.
I think you're good. I was just talking in terms of the reliability and the ownership piece. Who does that fall down to? Which side? No, but I think you did absolutely fine. Nice.
Yeah. I guess one of the core theses behind Griffin is that lots of companies want to offer financial services, and they're not just fintechs. So you'll every once in a while you'll hear Google and Amazon and Walmart all want to get into banking, but in the U.S. at least they can't because if you own more than 10% of a bank, you are now a bank holding company, and a bank holding company gets regulated as if it was a bank. And I think that happens in the UK as well. But anyway, like, a company like Google doesn't want to become a bank. Like, they know, their business is in ads. So really they want the data. And so after we have fintechs sorted, we want to do this kind of banking as a service for non-fintech startups or non-fintech startup companies, if that makes sense.
Okay.
So at the end of the day, someone, a Google and Amazon or whatever, they don't want to know about financial regulations. And so we kind of think of, we will handle that for you. We know what all the rules are, and we will define the API so that you can only do the things you're supposed to do.
Nice. Okay. In terms of, I think, summarizing some of the piece for non-closurists or closurists, if you want to step into an environment that has some interesting Kafka architecture, distributed systems, smart automated workflow, fast deployments, come and talk to these guys. Okay.
Yeah.
London-based, would you look at remote people?
Yes. We are. We've always been. We were remote friendly even before COVID. We're hiring in UK, Ireland, and anywhere that Boundless supports. Boundless is one of those PEO things that we use. So we're hiring for backend engineering, front-end engineering, which is like Clojure and Clojure scripts and browsers and that kind of thing, and then DevOps, infrastructure, SRE, whatever you want to call that role.
Nice. So if you're listening, reach out to Alan, reach out to any of the guys and girls in the business, check out their pages, drop the guys a note. You know where to go. Have you got anything else that you want to share with us at all that gives more context on Griffin, any advice points, maybe where to go and learn Clojure, anything that you want to share with us?
There's so many different ways to take that. I don't know which one to answer. Yeah.
I typically do that. I usually ask 2 or 3 questions at once. Sorry.
No, nothing really comes to mind.
Okay. Good. Okay. Like, share, comment, and retweet, rehash, all of the buzzwords when it comes to social. Check out the guys, griffin.sh. Check out Alan. Drop the guys a note. If you're interested in hearing a little bit more about what the guys are doing, obviously follow their website, follow their careers page. And Alan, it's been a pleasure. Thanks for sharing some of your stories with us.
Yeah, thanks for having me.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found at Engineers.io. It's no_. We've also got a website, which is Enginears.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.